This problem is very similar to our lab. You can see that the data here is very similar to what we collected in our lab. So the first question says how much copper was made. So all we need to do for this first problem is we need to look at the mass of the empty beaker and the mass of the beaker and the copper. So we are going to need to subtract. We're going to take 49.32 grams and we're going to subtract the mass of our empty beaker. So we get 4 grams of copper were made. The next question says how many moles of iron were used up in the lab. So again, we're going to look at our beginning and our ending mass of the nails, and we're going to have to subtract to find out how many grams we had. But this problem does ask us for moles, so we're going to have to convert from grams to moles. If we go ahead and subtract our beginning nails minus how much they weighed at the end, that's going to tell us how many grams of iron. So we now know that we've got 7.56 grams of iron that was used, but we want to know how many moles that is. So we're going to put moles on the top, and we're going to put the molar mass of iron on the bottom. What that does is our grams is going to cancel out, and that's going to give us our answer in moles. So when I take my 7.56 grams and divide it by the molar mass, I get 1.35 moles of iron. So if I look at the data table, I want to know how much aluminum was consumed. I can see the starting mass of aluminum was 14.76 grams. So that's how much I started with. I'm going to subtract what I ended with so that then that will tell me how much was used in the reaction. So we get 11.56 grams of aluminum. And then what if we had 3.2 moles of aluminum? How many grams would that be? So we're going to start with our 3.2 moles of aluminum. And we don't want moles anymore, so 1 mole is going to go on the bottom. And I want to find out how many grams that would be. So I'm going to look on my periodic table to see the molar mass of aluminum. So the molar mass is 26.982. And if I actually used up 3.2 moles, that would have been 86.34 grams of aluminum. So the first question on this problem says that all the magnesium chloride powder was used. How many moles would that be? So here's our magnesium chloride powder. We used 15.32 grams. We need to find out how many moles that would be. So we're going to need the molar mass of magnesium chloride. So I calculate that first and I get 95.211 grams is in 1 mole. So this is what I'm going to need to use in order to figure out if I have 15.32 grams, and I got that from the data table. I need to know how many moles that would be. So I know that 1 mole of the material is 95.211 grams. So you should get an answer of 0.161 moles of magnesium chloride. The next problem says Kia claims she used 2.56 moles of potassium. Is this an accurate statement? So we're going to look at the potassium. We're going to have to find out how many grams it is. And then we're going to need to convert that to moles. So according to the data table, that means that she used 8.56 grams of potassium. But we need to compare that to moles. So we need to find out how many moles this would be. So I'm going to look on the periodic table and see that 1 mole of potassium is 39.098 grams. So I'm going to convert 8.56 grams into moles. And you should get 0.219 moles of potassium. So I would then say that this is not an accurate statement because that is much less than 2.56 moles. So again, we have a data table. First question, what is the mass of potassium used in the reaction? So we're going to look at the starting mass and our final mass in order to calculate the mass of potassium used. So for the first problem, we're going to do 6.76 minus the 3.2, and we find that we would use 3.56 grams of potassium. Now we're going to convert that to moles, and remember, we're going to use the relationship that 1 mole of a material is equal to its molar mass. So we're going to look at the periodic table, and we're going to see that the mass of 1 mole of potassium is 39.098 grams. So if, according to our data, We use 3.56 grams of potassium. That's what we're going to start with. We're going to put our molar mass of potassium on the bottom because we want our grams to cancel out. And we're going to put 1 mole on the top. So we're going to take 3.56 and we're going to divide it by the molar mass of 39.098. So you should get 0.91 moles of potassium. The next question, how many moles of silver were created? So we're going to have to look at the mass of the beaker and the silver, which is 12.58 grams, and subtract the mass of the empty beaker first. When we do that, that's going to tell us that 4.02 grams of silver were created, and now we need to convert that to moles. So to do that, we're going to use 1 mole over the molar mass. The molar mass is going on the bottom because I don't want grams anymore, so I want it to cancel out. So I'm going to do 4.02, and then I'm going to divide that by 107.868. That's going to give me 0.037 moles of silver. Finally, the last problem has us starting with moles of silver chloride, and it wants to know how many grams that would be. So if we think about this, we're going to start with moles, and we need to get to grams. We know that 1 mole of a material is equal to its molar mass. So that means that we're going to need to calculate the molar mass of silver chloride to get this problem correct. So the formula for silver chloride is AgCl. Silver has a mass of 107.868, and then chlorine 35.453. So I add those two together, I find that 1 mole of silver chloride weighs 143.32 grams. Now I'm going to start with what I'm given, which is 0.56 moles of silver chloride. So since I don't want moles, 1 mole is going to go on the bottom, and my molar mass is going to go on the top. So I'm going to do 0.56 times 143.32, and you should get around 80.26 grams. So to do the first problem, I have to look at my starting aluminum and my final aluminum to find out how many grams of aluminum were consumed. I simply subtract these and get 11.56 grams. For my next problem, I need to find out how many molecules. Well, I know that 1 mole is equal to 6.02 times 10 to the 23rd atoms, but I'm given grams, so I need to know the relationship between moles and grams. So I use my periodic table and I find that 1 mole of aluminum is 26.982 grams. So 26.982 grams is equal to 1 mole, and I know that 1 mole is equal to 6.02 times 10 to the 23rd molecules. And so I'm going to solve to find out how many molecules of aluminum I have. And you should get 2.579 times 10 to the 23rd molecules. On the next problem, I'm given moles, and I'm asked to find out how many atoms. So I know this relationship, 1 mole is equal to 6.02 times 10 to the 23rd atoms. So that relationship is going to be used to solve this problem. I put moles on the bottom because I don't want moles anymore. I put atoms on the top because I want to find atoms. And you should get 1.926 times 10 to the 24th atoms. The next problem is going to take a little bit of analysis. First of all, my empty beaker was 5.32 grams, and my mass of my beaker with just my iron metal was 19.32 grams. So if I want to know how many molecules of iron were created, I first need to look at my data and figure out how many grams of iron were created. Now that I know how many grams of iron, I can now work on converting that to molecules. I know that 1 mole of iron has a molar mass on the periodic table of 55.933 grams, and I know that for every 1 mole of iron, I have 6.02 times 10 to the 23rd atoms. So now I can solve. Grams will cancel out, moles will cancel out, and I will have an answer in atoms. So I get 1.51 times 10 to the 23rd atoms. The next problem says only 3.5 grams of iron chloride were used. How many moles were used? So all we need to do is convert grams over to moles. And I know that there's a relationship between grams and moles. I can calculate that 1 mole of iron chloride has a molar mass of 126.839 grams by looking at the periodic table, adding the mass of 1 iron and the mass of 2 chlorines. Now I can use this relationship and what I'm given in order to solve for my moles. So if I start with grams, I want my molar mass on the bottom, and I want to find moles, so moles goes on the top. And so you should get 0.0276 moles of iron chloride. So the first problem wants to know about magnesium chloride and how many moles it would be. So I'm going to look at my data table. I see that there were 15.32 grams of magnesium chloride powder used, and it says if all of it was used. So that's going to be what I start with, 15.32 grams of magnesium chloride. So according to my problem, I don't want grams of magnesium chloride anymore, I want moles. So I know there's a relationship, 1 mole of any material is equal to its molar mass. So I'm going to use the periodic table and find the molar mass of magnesium chloride. So now I can use that relationship to solve my problem. And you should get 0.161 moles of magnesium chloride. Now, how many moles did Kia use of potassium? So we've got to look at our starting mass of our potassium and our ending mass of our potassium, find out how many grams that would be, and then we're going to need to convert that to moles. So my first step is I subtracted to find 8.56 grams of potassium. I got these numbers from my data table up here about potassium. Then I can go ahead and convert my grams of potassium into moles using the relationship that 1 mole is equal to the molar mass on the periodic table. And so when I solve, I should get 0.219 moles of potassium. Next problem, she claims she used up 2.56 times 10 to the 26 molecules of potassium. So we want to see if that matches up with these moles. So I can either go from moles to molecules and see if it's this number, or I can do the opposite. So I went ahead, I took my moles that I was given, and I'm going to find out how many molecules that is to see if it matches with the molecules she's claiming she used. So according to my calculations, if we used 8.56 grams of potassium, which is 0.219 moles of potassium, 0.219 moles of potassium would be 1.318 times 10 to the 23rd molecules. That is not the same as what Kia claims. So therefore, Kia is not correct. All right, so we have 15.32 grams of magnesium chloride being used up. How many molecules were used? So we're given grams, and we need to know molecules. So this is going to be an indication. This is going to take 2 steps. Mass to moles and moles to atoms. So here's what this setup should look like. We're given 15.32 grams of magnesium chloride. I know 1 mole is equal to the molar mass, so I'm going to calculate the molar mass and put it here. I also know 1 mole is equal to this many atoms, so I'm going to use that relationship as my second. So you should get 9.69 times 10 to the 22nd molecules. The first step for the next problem is to calculate how many grams of potassium so that then I can get over to molecules. So now I can go ahead and convert from grams to moles using the molar mass, and then I can find molecules using 1 mole is equal to 6.02 times 10 to the 23rd molecules. So you should get 1.318 times 10 to the 23rd molecules. All right, and our last set of problems here, you can see we're given molecules, so I'm going to use my 1 mole to Avogadro's number, but we want to find out grams, so my next step is going to be using 1 mole to the molar mass, and then I can find out how many grams I have. In the reaction, how many moles of potassium? Well, first I need to look at my data and subtract my starting potassium versus my final potassium. So that tells me how many grams, and then I'm going to use 1 mole to the molar mass to solve for how many moles of potassium. Finally, I'm going to take those moles of potassium and I'm going to convert to molecules so that way I can see if this is the correct number of molecules. But I see that 0.168 moles of potassium is 1.01 times 10 to the 23rd molecules. That is not what Rhonda is claiming, and so this would be incorrect. These numbers do not match here.